For example 3, we have a different type of function. We have a cubed power. So we will not have a parabola. This is going to be a little bit different. But again, our first step is to check to see whether our zero is on the right side. It is. So now we can create our function. So this is our, ooh, see? And this is why, never mind. Okay, I need to, okay. So f of x, I promise I'm not sick, but it's not like it matters because I am stuck in my house. Okay, so this is our function. This is our f of x, and it is greater than 0. So we determine whether it's positive or negative based off of our inequality, and we know that it is going to be positive. Once you've established whether it's positive or negative, you can write your equal sign, and then we go about solving it regular. So because your x's are raised to different powers, we have a 3 and a 1, you want it set equal to 0. So you should not move this x to the other side or the x cubed. That will not help you solve this. So we need to factor. Remember, pluses and minuses separate your parts. So we have this one part and this one part. So we have a total of 2 parts, and they both share an x. So we are going to factor out that x, okay? And then continue to write the rest of the problem, okay? So if I factor out an x, that's just like taking away an x. So that leaves us with the squared minus, and then we're left with nothing. But in this case, nothing is 1. Because when you're factoring, that means you're dividing, right? And multiplying and dividing, nothing means 1. And adding and subtracting, nothing means 0, okay? So here we have something times something is equal to 0, so we can set both of these somethings equal to 0. So I'm going to do that. So x is equal to 0, and x squared minus 1 is equal to 0. So if I go about solving this, we only have one x, so I'm going to get that x by itself. So I'm going to add that 1 on both sides. And then to get rid of a squared, we take the square root. And does anyone remember what happens when you take the square root? You always get a what? Plus or minus. So here we have x is equal to plus or minus the square root of 1 is just 1. So for our critical values, we have x is equal to 0 from this first one, and x is equal to negative 1. And positive 1, okay? So now we can go about solving this using way 1 or using way 2. It's going to be a little bit different using way 1 because we don't have a parabola, so we don't necessarily know what the graph looks like. For this one, we can talk in behaviors. So let's see. So I'm going to write, let me do this in a different color. So I'm going to make a little chart, I guess. I don't know what this is called. But we have negative, positive. Kind of reminds me of chemistry when they used to make those Pundit squares. I don't know what it's called, but yeah. So we have positive, we have negative, and then we have even, and we have odd, okay? So this is going to be in relation to whatever your highest power is, and whether whatever is in front of it is positive or negative, and then whether the highest power is positive or negative, okay? So just looking at examples, let's start with x squared. So we know that x squared looks like this parabola, right? The highest power is 2, it's even, and it's positive. So that means you see the end behaviors, they're both pointing up. So when it's even and positive, they're both pointing up, and you don't know what's going on the inside, okay? So now, let's say we were graphing negative x squared. So you have to ask yourself, is this affecting your x, or is it affecting your entire function? Remember, if it was affecting your x, this whole thing would be in parentheses. So this is actually affecting the entire x squared. So when you're affecting your function or your y, that means you flip over your x-axis, okay? So here, this would flip completely downward, so we'd have a graph like this. So when the highest power is even and it's negative, your end behaviors are both pointing down, okay? Now, let's go to x cubed. Hopefully you guys remember what that looks like. It goes from the bottom to the top, okay? So for our end behaviors here, at first it's going down when it's positive and odd, and then it's going up. And then remember, whenever you have the negative, this negative is affecting the entire function. The function is a fancy way of saying y, so it's affecting our y, so we flip over our x, which means it's going to now look like this, okay? So now, we are pointing up first and then pointing down when we have a negative and an odd, okay? So for this specific problem, when we look back at our function, our highest power is odd and it's positive. So if I go over here, we have positive odd. So we know that the first thing that we're going to be doing is going down, and then we're going to be going up, okay? So I'm gonna go ahead and write this problem again, and then I'm going to write what our end behaviors are doing, and then I'm going to write our critical values, so we can go from there, okay? Cool, so this is our original inequality. We know that it's going from starting at the bottom, pointing down, and then it ends going up. And these are our critical values, okay? So now, for way one, if we're looking at this on an XY plane, we know that it's going to cross at -1, 0, and 1. So at the very far end, we know we're pointing down. And at the very right end, we know we're pointing up, okay? And then the cool thing about these, it's always going to make squiggles on the inside when you're working with basic polynomials, okay? So because this one was going up, the only way to go from here to the next one would be to make a U shape, like a rainbow. Sorry, I guess the upside down U. So to make a rainbow. And then to go from the 0 to the positive 1, we'd make the U shape, okay? So that is our graph. And now, again, we're looking at our box, and our box only shows up when you have a 0 on the other side. Our box is greater than 0, so that is going to be our positive values, which means we want everything above our x-axis. So we want this and this. So now if we were to write that in interval notation, this is going to be -1 to 0, and then 1 to infinity, okay? So to determine whether we use parentheses or brackets, we look at the sign of our inequality. This inequality is greater than, there is no line, so we use parentheses and we separate it with our union. And that would be our final answer, okay? So if you do not like that way, feel free to use the second way, which again, you will have to use when you're working with fractions. But for the second way, we write it on a number line. We have our critical values, -1, 0, and 1. And we pick numbers in between each of those intervals. So if I pick a number between these intervals, here we could do 0.5, here we could do -0.5, here we could do 2, and here we could do -2. And again, we need to plug these into the box, okay? And the box only shows up when there's a 0 on the other side. Can't stress it enough, okay? So we have our box, and we go and we start plugging in. If we plug in a 2, it's going to be 2 times 2 times 2. And then we have -2, so that's still going to be positive. Then we plug in our -1/2, and then we plug that in. We find out that it's negative. We plug in a -1/2, and we get a positive. And then we plug in our -2, and we get a negative, okay? Another way to do this more quickly than just plugging it in, remember we have our calculator trick. Instead of x, remember in your calculator you write answer. So this would be answer cubed minus answer, right? You hit equals to save it. And then we go about plugging in our answers. So then we do -2 equals, then we go back up and hit equals, and it's going to give you a negative number. Then you do -0.5 equals, go back up, check it, and it's going to give you a positive. Then you do -5 equals, go back up, equals, and it's going to give you a negative. Sorry, I think I said negative here, positive, then a negative. Then you hit 2 equals, go back up to original problem, hit equals, and it should give you a positive, okay? So again, you don't have to do this by hand. You can use your calculator if you need to. But yeah, so after we have figured out what those intervals, whether those intervals are negative or positive, we look back at our inequality. We want everything that is positive, so we're taking from here to here and here all the way to infinity. So again, we have -1 to 0 and 1 to infinity, and because there is no line, we use parentheses. So we end up with the exact same answer. The gray marker is kind of running out.